Hey everyone, let us discuss about the syringe pump. Syringe pump, a medical device which is used to administer small amounts of fluid to the patient via the syringe. It is also used in biomedical research centers as well as chemical labs. Now let us look at the apparatus of the syringe pump. This is the syringe pump and these are the syringes which are used to deliver fluid to the patient, and this is the intravenous tubing which connects the syringe pump to the patient. Let us look at the working principle of the syringe pump. The fluid which is present in the syringe will be given to the patient via the intravenous tubing. So, the piston of the syringe is pushed by the plunger. As a result, the fluid which is present in the syringe will be going into the patient via the intravenous tubing. Now, let us discuss about the parts of the syringe pump. This is the syringe barrel detection, and this is the clamp of the syringe barrel detector. This is the plunger which holds the syringe and it is able to move in and out. Now, let us discuss about the displays of the syringe pump. This display tells that the lamp flashes when the infusion line is overloaded or plunger is overloaded. This is a syringe size display. The 10, 20, 30, 50 is displayed. If the syringe is not set properly, all the lamps are going to flash. This is the battery lamp. This lamp flashes if voltage of the built-in battery becomes low. If the lamp flashes when the lamp is considered to AC power, if it is alarm for the battery deterioration. Near empty alarm. This is the near empty alarm. This lamp flashes when the fluid is in syringe becomes nearly empty. End alarm. This is the end alarm flash. This lamp flashes when the infusion is completed. Switch. Silence switch. This lamp is used to stop the alarm sound. After removing the case of alarm, press the switch to clear the alarm lamp. Flow rate display. This is the flow rate display. This set flow rate is displayed. The set flow rate is displayed. Press ML switch to display the total volume delivered. Reset total volume switch. This is the reset total volume switch. Press the switch together with ML. These two press. These if you are pressing the press total volume switch and the ML switch to reset the total volume delivered to 0. Press this switch twice together with the rapid switch to plunge the line. This volume of plunging is the total volume. Power switch. This is the power switch. This switch turns the power on or off. Press this switch continuously for 1 second to turn the power on or off. Now let us look at the internal parts of the syringe pump. As we already know, this is the syringe barrel detector which can move up and down. While it is moving up and down, it is connected to the potentiometer. When it is moving up and down, the resistance of the potentiometer changes. As a result, the changed resistance will be displayed in the form of the amount of the syringe that it holds. Next, coming to the stepper motor. This stepper motor is connected to the gear motors, and this stepper motor and gear motor will move in the opposite direction. That is, if the stepper motor is moving in clockwise direction, these gear motors are going to move in anti-clockwise direction. What is the importance of gear motors is, the gear motors are the mechanism that adjusts the speed of the electrical motors, leading them to operate at a certain speed. After that, here at the bottom of this stepper motor, we have a near empty sensor. As we all this is the near empty alarm. This is the near empty flash. When it is going to flash means when the plunger when the plunger position is almost when it reaches this near empty sensor, then it will sense and that alarm is going to flash. And at the bottom of syringe pump stepper motor, we have another sensor which will detect the end position sensor. Now I have taken the fluid into the syringe pump and connected the intravenous tubing to another end of the syringe. Now I am placing this syringe in the holder. See, before these were blinking because I have not set it properly. After putting this barrel detector down, this is set to 50, indicating that this syringe pump can hold 50 ml of fluid. Now first I have set the flow rate by using these buttons. These upper ones are for to increase the number and lower ones are to decrease the number. I have set the flow rate of 100 milliliter per hour. Now I am starting the device. Press this button to start the syringe pump. You can hear some noise, that is the motor noise which is running inside the syringe pump. From the other end of the intravenous tubing, we can see that the fluid is coming out at the flow rate we have set. See here, we can near empty alarm is blinking because the fluid is almost completed. Also the end button is also blinking because the total fluid which is present in the syringe have completed, so we are getting the end buzzer and the near empty buzzer. This is the infusion device analyzer which is used to calibrate the syringe pump as well as the infusion pump. This is manufactured by the company Fluke and the model number is IDA5. It has 4 channels. Now let us look at the connections of the syringe pump with the calibration device. Now I am calibrating the syringe pump. Till now we have seen how the syringe pump works. Now we are seeing how we should calibrate the syringe pump. So the intravenous tubing which is connected to the syringe must be connected to this calibration device to the channel which we are using, and after that at the back side of the infusion device analyzer, which channel we have selected in front, that channel only we must connect another tube. Press enter to proceed. After this, now it is set up. This is flow, this is occlusion. We'll go for the flow. Now enter the flow. Start. Again enter. First one will represent the average flow, that here we have set the 200 ml per hour, and the same is representing here but with plus or minus 5 error. Next is the volume in ml. Next is the elapsed time, like what is the time when we have started the syringe pump. And next is the instant flow, like what is the flow rate at that particular instance. Back pressure is the resistance or force opposing the desired flow or fluid through the pipes, leading to friction loss and pressure drop. Now let us see the graph of this flow. This is the graph. Same, the average flow, the instantaneous flow, the total volume, the elapsed time. The x-axis will indicate the time and y-axis will indicate the ml per hour. These two values are matching with plus or minus 5 error in the infusion device analyzer. From this we can say that the syringe pump is calibrated.